Let us solve the equation x squared minus 2 equal to 0 by using bisection method. Of course, bisection method gives us the approximate value. Let's try to determine the approximate value. For that purpose, we take fx equal to x squared minus 2. Then f of 1 equal to 1 squared minus 2, and that is minus 1. F of 2 equal to 2 squared minus 2, and that gives us 4 minus 2 is 2. We observe that f of 1 is negative and f of 2 is positive. Let's draw a rough graph. We have x-axis and we have y-axis, and we have x equal to 1 here, x equal to 2. F of 1 is negative, somewhere here we have minus 1. F of 2 is positive, 4, somewhere here. Now f is a continuous function, so the graph, we don't know what exactly is it, but somewhere we find that the graph crosses the line y equal to 0. So we know that somewhere here, wherever the graph intersects x-axis, we have a root of the equation fx equal to 0. Let us find the midpoint of 1 and 2. 1 plus 2 by 2. That is equal to 1.5. Let us find f of 1.5. F of 1.5 equal to 1.5 whole thing square minus 2. That is equal to 2.25 minus 2, and that is equal to 0.25. So we observe that f of 1.5 is also positive. F of 1.5 is equal to 0.25, and that is positive. First of all, we have observed that we have fx equal to 0 somewhere between 1 and 2. f1 is negative, f2 is positive. Also, as we have seen earlier, f1 equal to, let's look at the table calculation before, f1 is minus 1. f1 equal to minus 1, that is negative. So again we have a change in sign. So it must be that we have a fx equal to 0 for x somewhere between 1 and 1.5. Let's find the midpoint of 1 and 1.5 once again. 1 plus 1.5 by 2. That gives us 2.5 by 2. That is equal to 1.25. Let's calculate f of 1.25. F of 1.25 equal to 1.25 whole thing square minus 2, and if you calculate it, it will come out to be negative. Again, we know that f1 is negative, f1.25 is also negative. However, f1.5 is positive. So we can say that there is change in sign. First we observe that f of 1.5 is positive and f of 1.25 is negative. So we observe that there is a change of sign. So we observe that there is a change of sign. So there must be some x such that fx equal to 0 and x lies between 1.25 and 1.5. Let's find midpoint of 1.25 and 1.5. 1.25 plus 1.5 by 2. That is equal to 2.75 by 2. And that is equal to 1.375. Now, once again, if we calculate f of 1.375, that will turn out to be negative. However, f of 1.5 is positive, but f of 1.5 is positive. So once again, we observe a change in sign. So we know that some x exists between 1.375 and 1.5 so that fx equal to 0. Let's calculate midpoint of 1.375 and 1.5. 1.375 plus 1.5 by 2. That is equal to 1.875 by 2. That is equal to 1.4375. Let's calculate f of 1.4375. f of 1.4375. If you calculate it, you will find it to be positive. However, f of 1.375 is negative and f of 1.4375 is positive. F of 1.375 is negative and f of 1.4375 is positive. So we can say that there exists x so that fx equal to 0 and x lying between 1.375 and 1.4375. Let's find the midpoint of those two. 1.4375 plus 1.375 by 2. That gives us 5 2 0 7 2 by 2. That is equal to 1.35125. Again, let's find the value of f of 1.4375, 1.375. So 2.7. Yeah. Okay. Let's find f of we made mistake. Uh, 5. 7 plus 5 is 12. 5. 7 plus 5 is 12. 7 plus 3 is 10. 10 plus 1 is 11. 4 plus 3 is 7. 7 plus 1 is 8. 1 plus 1 is 2. 2.8125 by 2. That is equal to 1.40625. Let's find f of 1.40625. That will turn out to be negative. Earlier we have observed 1.4375 to be positive, f of 1.4375 to be positive, f of 1.4375 to be positive. So I can say that there exists a root of fx equal to 0 that lies between 1.40625 and 1.4375. So we can say that f of 1.4 is nearly 0. So we can have solved the equation x squared minus 2 equal to 0. And it turns out that x is approximately 1.4 but only up to 2 digit of significance, up to 2 digit of significance. We can proceed further and we'll get higher and higher accuracy that we can do it.